Welcome, my dear students, for joining the class. Now we start our lesson. The lesson is properties of behavior of gas. We are familiar with three types of a matter. There are three states of a matter: solid, second one liquid, and third one is gas. Now, a particular substance can be in three types of states: solid, liquid, and gas. Say the solid form of water is ice. When ice gets heated at a particular temperature, it gets melted and it is converted into water. Melting point of ice is 0 degrees Celsius under normal pressure. And when water is boiled at a temperature of 100 degrees Celsius under normal pressure, it is converted into vapor. So, vapor or steam is the gaseous state of water. Now, our discussion will be limited in gas, properties of gas, how the gases behave under different pressure, different temperature, etc. So before going to that, we have to first mention that a particular mass of gas, though it has a particular mass, but it has no particular volume. Mass fixed, but volume of particular gas, particular mass of gas, not fixed. So on which factors the volume of a gas depends. If a gas is certain mass of gas is kept in a container, it will get the volume of the container. Say this is a container. There are a fixed mass of gas, and the gas will get the shape and volume of this container. If the pressure is increased, then its volume will be decreased. So keeping the mass constant and temperature constant, when pressure increases, volume of the gas decreases. So we have to get a clear idea about pressure. What is pressure? Pressure is the force applied on unit area perpendicularly, and pressure of a gas is the force applied perpendicularly on unit area in a closed container. So force by area equal to pressure. This is the formula of pressure. Now, what will be the units of pressure? In CGS, unit of force is dyne and that of area is centimeter square. So in CGS, unit of pressure is dyne per centimeter square. In SI, it will be Newton per meter square. And this Newton per meter square is also called Pascal. Now, 1 Pascal is equal to 1 Newton per meter square. When 1 Newton force is applied on 1 meter square area perpendicularly, then it is called 1 Pascal pressure is exerted by the gas. Now we have to know the relation between Pascal and dyne per centimeter square. Relation between Pascal, it's abbreviated form is Pa, and dyne per centimeter square. Now we know that 1 Pascal equal to 1 Newton by 1 meter square. You know in the earlier class 1 Newton equal to how many dynes? Yes, 10 to the power 5 dynes. 1 Newton equal to 10 to the power 5 dynes. Don't write plural because units are not will be not in plural form. 1 meter square equal to 100 centimeter, that is 10 to the power square centimeter into 100 centimeter square. Get the idea clearly. 1 meter square equal to 1 meter into 1 meter, that is 10 square centimeter into 10 square centimeter. That is 10 square into 10 square centimeter square. Not 1 meter square equal to 100 centimeter, but 100 centimeter into 100 centimeter. So 10 to the power 5 by 10 to the power 4 dyne per centimeter square. That is equal to 10 dyne per centimeter square. So the relation is very clear and very simple. 1 Pascal equal to 10 to the power dyne per centimeter square. Other than these, Pascal and centimeter dyne per centimeter square, there are so many units of pressure. A big unit is bar. 1 bar equal to 10 to the power 6 dyne per centimeter square. Millibar, milli, keep in your mind that milli means 1 by 1000. Millibar 1 by 1000 into 10 to the power 6 dyne per centimeter square. Such as millimeter 1 by 1000 meter, milliliter 1 by 1000 liter, milligirl 1 by 1000 girl. That is a very minute particle or minute quantity. For expressing the minute quantity we use milli. Now pressure is also expressed by atmospheric pressure. 1 atmospheric pressure means normal pressure. Normal pressure means pressure of 76 centimeter mercury. So now normal pressure. Normal pressure, it is also called standard pressure. Normal pressure equal to pressure of 76 centimeter mercury column. That is equal to height of mercury column 76 centimeter into density of mercury at 0 degree Celsius, that is nearly 13.6 gram per cc, into acceleration due to gravity 980.6 centimeter per second square. That is equal to nearly 1.01325 into 10 to the power 6 dyne per centimeter square, or it also be called 1.01325 into 10 to the power 6 by 10 to the power 5 by 10 Pascal, that is 10 to the power 5 Pascal. I think you have understood that 1 Pascal equal to 10 dyne per centimeter square. So 1.01325 into 10 to the power 6 dyne per centimeter square equal to 1.01325 into 10 to the power 5 Pascal divided by 10. So this is the relation between normal pressure and Pascal and dyne per centimeter square. Normal pressure means pressure of 76 centimeter mercury column, and that pressure is converted into dyne per centimeter square 1.01325 into 10 to the power 6 dyne per centimeter square, and when it is divided by 10, it becomes Pascal, that is equal to 1.01325 into 10 to the 5 Pascal. So it is clear we have got the relation between normal pressure, it is converted into Pascal, it is converted into dyne per centimeter square. This is called standard pressure. Now we have to know about standard temperature. Standard pressure means pressure of 76 centimeters mercury at 0 degree Celsius. We have to mention it. Pressure of 76 centimeter mercury column at 0 degree Celsius. You may ask a question, what is the utility, what is the necessity of mentioning 0 degree Celsius regarding mentioning the pressure of 76 centimeter mercury column? Because the density of mercury changes with the change of temperature. So which mercury will be taken and at which temperature, under which density the pressure will be determined. We will take that mercury, we will take the calculation of mercury at 0 degree Celsius. At 0 degree Celsius there will be a fixed density and that density is 13.6 gram per cc approximately, and taking this we calculate the pressure, normal pressure. Now the normal temperature equal to 0 degree Celsius. Later we will be able to know it will be equal to 273 Kelvin. So this is normal temperature. So the question is that what is NTP or STP? What is normal temperature or standard temperature and pressure? What is STP? It is also called NTP. S means standard, N means normal. So standard temperature and pressure, in other words, normal temperature and pressure. Normal temperature means pressure of 76 centimeter mercury column at 0 degree Celsius. You have to mention 0 degree Celsius with pressure, and normal temperature means 0 degree Celsius. So collectively, normal temperature and pressure means pressure of 76 centimeter mercury column at 0 degree Celsius and a temperature of 0 degree Celsius. And always, normally, the pressure volume of a gas is measured at NTP or STP. But when temperature and pressure are changed, then volume of a gas is changed. Why the volume of a gas changed? Volume of a gas changed due to change of pressure and temperature. What is the reason behind this? In a gas, the molecules are not closer to each other. Between the gas molecules, the intermolecular force of attraction decreases and it nearly becomes zero. So gas molecules are always striking on the wall of the container at random. It has greater speed and they are always exerting pressure due to their speed. Intermolecular attraction is almost zero and intermolecular distance is increased infinity. So the gas molecules always try to be escaped from the container and they has no particular shape, has no particular volume. So on which two factors volume of a gas depends? Volume of a gas depends on two factors. One is pressure and one is temperature. These are the two main factors on which volume of a particular mass of gas depends. Without mentioning the pressure and temperature, if you mention some volume of gas, that will be totally defective. So you have to mention pressure and temperature regarding mentioning the volume of a gas. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.